This conference will now be recorded.
Okay. Hi guys. Thank you for tuning in. It's a great day, to have our guest today. Our meeting today is gonna be we will with Jordan. He's from the United States. He's a certified SolidWorks expert and senior industry process consultant at Dassault Systèmes. And also we have Andrew. He is from Massachusetts in the United States. He's industrial process consultant at Dassault Systèmes. Hi guys, hi, nice to meet you.
Hey, nice to see you,
Hello.
Mohammed. Thanks for having us today. We're big fans of, all that you're doing with your user group. It's very impressive, the guest list that you put together. So kudos to you for setting this all up.
Awesome.
Yeah.
And thank you for pointing out that I'm a senior industry process consultant versus Andy is just being a industry process consultant.
Just a lowly non-senior industry process consultant.
Our topic today is gonna be very unique about interactive pattern creation with xGenerative design, as I said. So it's really cool. So feel free, guys, if anybody has any question, to post it in message or wait until the end of the meeting. We will be open mic in order to ask your question. So I'll leave it to you guys. Let me stop my screen share. Oops. This is my render.
Oh, that's a nice render.
Nice.
I took it away from you. I want to see that more. But
so that
I'll go ahead and get started. Maybe we could come back to that towards the end. We've got, so today we're going to be working on the 3D Experience platform. And this, Andy and I, when we join user group meetings, we were talking about it. And we did have some videos that we could show and some latest and greatest information, but we're like, no, we got a demo live. So we picked a brand new data set that we're going to try to model for you live from scratch. And to be honest, we haven't even clicked through the entire thing before. So this should be an extra exciting and suspenseful episode. But what we're looking at doing is we're looking at this old miter saw data set, and we were thinking, this is a good opportunity to talk about the difference between old SolidWorks surface modeling, something like this, and SolidWorks X-Shape, which I believe you had Jason Pohl on a previous episode, and he went through, modeling a German Shepherd or something like that.
yeah.
Yeah. So I don't know how he came up with that. Here we'll actually be modeling a product this time, just to show you that it can be used for more precise geometry, where rather than free form sculpting, which is what it's known for, it could be used to create actual engineering products. And then Andy is going to show you in a little bit a really cool workflow, brand new product that allows you to apply patterns and all kinds of really cool shape generation to a model like this. So what I'm doing is I'm getting started with a what I would call is just a digital hunk of clay. And this is what you saw Jason use the other week, doing the push-pull surfacing. And I've got a sketch, a hand sketch in here just for reference to make sure I make everything the right size. But of course, I can switch any view. Now, over here is a little subassembly from that miter saw assembly. And I have the actual geometry in here to reference as I build this handle. Now, while I'm building, it's pretty cool, right? Because you saw the push-pull surfacing, but I'm going to try to show you a few features that Jason might not have covered the other week really quick. And that is, if I select opposing faces, I could punch a hole right through there. And you could imagine just how many features that would take in SolidWorks to go ahead and create, because what we're doing at every time we make a modification to this model, all the geometry, you see how smooth it blends from face to face. It has an automatic C2 level of curvature continuity, which in like product design, that's really important. That just ensures that there's really smooth transitions from one face to the next. And you know, I can manipulate this little robot on screen. This is a main UI interface right here. If I drag an arrow, it translates the geometry. If I rotate the ring, it rotates it. And then if I do what I just did, and I select all these points, I could grab a dot or hold down a keyboard shortcut to scale in all directions at once, whether in that linear direction, just one, or all of them. And that is, right there, is all the training you need to start using this tool. Now, I mentioned that like it could be used for, you know, engineering more precise applications than just a German Shepherd, right? So here's the unique workflow. I'm going to I want to subdivide these faces because I want more points in this localized region. And I also want the edges to be sharp. So we don't always have to have, you know, perfectly smooth edges. That purple edge now represents a sharp edge, and you'll understand why I'm doing that in just a second. I'm going to scale this up a little bit. Let's see here. And scale that in. And what I'm doing is just kind of looking at each one of these edges, making sure they're about equal length. The reason I'm doing that is because I'm going to select each one of these edges, and then I'm going to actually select geometry from the model itself. So that little ring right there. And you see on the pop-up context toolbar, just like SolidWorks, it's always recommending to me a tool from, you know, based on what I've selected. Let me go do that again. Hang on here.
I think you just waited too long.
Yeah, it's getting impatient with me.
Yeah.
Let's select
Jordan's
these.
a talker.
And then yeah, there we go. There we go. All right. So look at that. What it did, that edge from the geometry in the original assembly. And by the way, let me step back here for a second. Everything that that I showed you today was actually created. The original assembly was created in SolidWorks right here. And if I come over to the back to the web page, and this again, I'm doing this all on an internet browser like Chrome. You'll notice here in the tree that everything has a little SW red pill icon right there. That tells me that all this original geometry that is currently transparent, and here I could go ahead and show it all. So that is the original geometry that was created in SolidWorks. And so I'm designing around it and linking to it, and it's a pretty cool workflow. Actually, let me hide it for a second because I want to select these faces. And one of the amazing things about this, Mohammed, is these faces right here are perfectly flat. So if I brought this back into SolidWorks, I could click that face and start a sketch on it, which is really nice. So there is a really high level of precision. Andy, to wrap this up, what do you say I make your job a little bit harder, because I think you're going to want to add a pattern over here.
Yeah,
so
I'm gonna add the grip pattern.
Yeah, I'm gonna make your job harder. It's like way too smooth and simple of a surface right there.
Yeah.
So I'm gonna subdivide it a few more times by adding a few more loops. And let's spread all this out a little bit. And I'm just going to go wild, grabbing these points and maybe adding like a little index finger indentation right there. Maybe pulling this out a little bit. Maybe this down. A little more contoured. What do you say? You're probably
I can do it.
This. You think?
Wait,
How about this? What if I do this a little wider?
In two directions? Come on, man. Difficult.
All right, let's let's keep on. I'm just going to fine tune this a little bit. One more finishing touch that I want to apply here, Mohammed, before we move on to the star of the show, Andy. I also want to point out that, like, you know, we do have fillets in this, you know, but fillets are constant curvature. And when we're concerned about, you know, curvature continuity and smoothly blending from one face to the next, we can crease the edges, as I mentioned, which like perfectly sharpens those edges, but we can also apply a smoothing factor. So it's not a constant radius fillet, it's slowly changing curvature to sharp and then smoothing back out to the surrounding faces as we go. And that's pretty cool because to do that inside of SolidWorks, we do have a curvature continuous fillet, but it's a lot more work to apply than what I just did right there very quickly. So I'm going to unapply that little smooth crease that I applied to that geometry. And then let's go ahead and shrink down these two faces too, because it looks a little bulky. So I'll go ahead and get something like that. Maybe to make it look less bulky or boxy, I can round that off. Andy, I could go on and on for all day long, but for now, how does this look for you? Okay.
Yeah, I think it looks great. I think if you just want to create a kind of, well, do you want to create where we're gonna like kind of slice off the area that I'm gonna put the pattern on? Like, do you want to section that out, or do you want me to do that?
It's up to you. I could do
I
it if
think
you want.
you're already in X shape right now. Why don't you just do it?
Okay, cool. So what we'll do is this is kind of a cool workflow. I'm just going to create a surface, a sub D surface. And what this allows me to do is, I'll just place it in. What do you think, Andy? We probably don't need as many subdivisions right here.
Right.
And then from the top, let's just plop that into place.
Yeah,
I'll come
and you
into
can
this
just rotate
view
it around.
and rotate this around 90 degrees. And we'll bring it over here. And Andy, I think what you're asking is, can I use this surface to go ahead and kind of slice out a section for you to, like a region for you to apply your pattern to, right?
Right.
All right, so I'm gonna add these little points right here, and then maybe you tell me what looks good. Just kind of like wrap it around right there-ish.
Yeah, I think that looks like a good area to me.
Should I bring this back a little bit more, or is that too much curvature for you to?
I can handle it, man.
All right, okay, fine. So what we've just done here is just like that, created a surface body. One of the huge benefits of 3D Sculptor is, and that's the role name, and the app name is XShape. It allows you to model live, right? So what you saw Jason do the other week, everything that he does, he's doing it live as he's going. And you know what, Andy? We only need the surface for yours, right?
Correct.
So let me delete that that guy right there. We have two surface bodies.
Yeah, why don't you put that other surface body in a separate ordered geometrical set?
Sure.
And the cool thing, so we have these things called ordered geometrical sets, which sometimes we use them as like just like a way to separate out bodies. Like in SolidWorks, we just have a bodies folder. We have a surface bodies folder and a solid bodies folder.
Does it really matter to separate that out, Andy? We just want the final surface to be in an ordered geometrical set, a unique one, right?
Well, I'm going to do the split inside of xGenerative design.
Okay, so just leave it like this.
Well, inside of xGenerative design, I like to have it in two separate ordered geometrical sets, just because it's easier to turn them on and off and visualize them quickly. The really cool thing about ordered geometrical sets, though, is the fact that when I'm using ordered geometrical sets, I no longer have to worry about different feature history. Like right now, for instance, if Jordan wanted to go edit the handle, he could edit the handle while he's looking at the split surface.
So check this out. The surface that I created was downstream in the feature tree, right? And we know that if you did that in SolidWorks, once I edited this original shape, the downstream features would disappear because they're dependent on the upstream features. But by putting these in separate folders called ordered geometrical sets, this is kind of like some power that we're borrowing from CATIA. It allows us to make changes upstream while still referencing the downstream features, which is really, really cool and kind of fascinating, because there's really, unless you're in an assembly or something like that, there's no way to do that inside of SolidWorks. So Andy, is this all you were looking for, or did you want me to perform the split feature too?
Yeah, no, that's great right there.
Okay, all right.
Yeah, you can just go ahead and click save. And I will take over at this point. And the first thing that I'm gonna do is just kind of give you guys here, I just want to set up my screen so I can see what I want to see and not see what I don't want to see. And what I want to see is all your smiling faces. But you guys can see my screen. You see the crazy bridge?
Yeah, it's real now.
Yeah. Okay, cool. So what I wanted to do is just kind of start off with, hey, like this is kind of the bare bones basics of how you might set up a pattern from scratch. And then we can, my aim is to make sure that it doesn't look like magic, right? I want you to understand, like, hey, we're just setting up some rules, and we're going to use those rules to tell it what to do. So the first thing I'm going to do actually is go into 3D Sculptor, and I'm just going to put this over here. And I want to just, I'm just going to create like a random shape real quick. I could have been doing this while Jordan was doing it, but I don't know what I'm doing. All right.
Live.
So we're just going to call this test pattern example. I probably have 50 different physical products with some combination of those words, because I'm just like constantly creating things like this. But anyways, in here, I'm inside of X-Shape. I'm going to create a surface sub D, and that looks pretty good. And maybe I'll stretch it here, and just for fun, I'll kind of make it a little bit interesting. Move that out this way, and
your skills are amazing.
Yeah, I've been practicing. I learned most of it from probably the greatest sub-D'er in the world, Jason Poole. I'm just taking shots at Jordan. Not to discount either of them, they're both extremely talented. So now I will go ahead and save this, and then what's also really nice is I can just, I'm already working on this, and just drag and drop it over there, and now I'm opening up that component inside of xGenerative Design. So now I want to create a pattern on the surface, and I'm just going to do like a simple pattern from scratch. Just going to load everything, and now I'm in xGenerative Design, and I have a few different ways that I can work with this. I can work in the graphics area. So what I could do is I could actually just select, I could go down to my tools here, and I could say I want to do an intersection, and I want to do an intersection between this plane and this sub D, and click OK. And now I could say that intersection, I actually want to divide that up. So I can go here and say divide, and I could divide that by as many points as I want. So now I've taken that curve and I've divided it by a bunch of different points. So we actually have a tool in SolidWorks that's very similar, called the segment tool, right? You search in your command search, you can search for segment, and you can put
Place
segment line out. Yeah, place points on the curve, or you can even segment them out. But this is also taking into account like the curvature of it, right? So they're all the same curve length. So it's almost like if there's a string, you could straighten it out and they'd all be even. So then I could, well, what I'm going to do right now is I'm working in the graphical area. What I'm going to do right now is switch to this thing that we call the graph editor. So if I click on this, what I've actually been creating is these nodes. These nodes exist in here, and this is all the stuff that I just created. I did this input, which gave me this subdivision surface. I intersected it with the YZ plane, and then I put it into this divide curve, and I have 10 outputs there. And if I change this to 15, it changes over here, right? So now I'm going to use those points, and I'm going to say plane, and this is, I also love this. I can just drag away from here and start searching. Plane normal. So now what I want to do is this is my curve, and for every point, I want to plane normal to that curve. And I go, actually, that's not what I wanted. What I really wanted was, I wanted a plane offset point. So now I say a plane that is parallel to the ZX plane. You see how it's cross highlighting always. And at every point, I want it to be parallel to that. So now you can see the difference is one's kind of staying like keeping the normal constant, if you will, to reference SolidWorks and how sweeps work.
So for the audience, this is completely foreign from anything you've ever seen with solid modeling before. That's okay. This is a completely different way of modeling. It's all kind of like logic based. It looks more kind of like a programming language versus your typical feature tree. The idea, the way that it makes sense in my head, Andy, is that with SolidWorks, we have a bunch of features, and those features are jumbled chunks of programming code that help guide you through making common geometry. And what this application has done is taken all that code and shattered it so that you can use any piece of it in any combination to create the unique types of geometry. The features are not predetermined. You get to use all the code at once to kind of like program it together as you go.
Yeah, absolutely. And one of the cool things about this is the fact that it's with parametric modeling. Parametric modeling is a double-edged sword, okay? Because it's parametric, if I make an update somewhere downstream, it's going to update everywhere, right? And the double-edged sword of that is, if I make a change, it updates everywhere, right? Sometimes that's frustrating. It's a problem. And what this program does is it's not the same history-based sort of modeling where I have things that happen at certain times in the tree, right? What it actually is I have access to every point of this model at every point in time, and I can always reference it. So time does not matter here, which is pretty cool. So one of the other things I really like about this is I can click on this. I can click on any node and get basically like SolidWorks help right in here. Like it lets me know what it is. So what I'm going to do here is I'm just going to run through a little bit more of this. I'm going to do another intersect, this time with the same geometry. And I know I'm going to reference this geometry a bunch. So I'm actually going to, I'm actually going to say it's a favorite. And now when I'm down here, I can go to favorites and I can reference subdivision, right? So now I've intersected it wherever those planes are. And now I can do another divide curve, and it gives me another number of instances, right? So now I could say, hey, I want 10 in this direction. So now this has given me this grid of points, right? Now, I could then say from each one of these points, I want to make a sphere on each one of those points that's a proper distance away from the next point, right? And I can call up that distance. So I've actually already created a way to do that. I've grouped together some nodes and created what we call a controller. So I could grab any group of nodes and say, I want to create not a controller, I'm sorry, a user operator. So I can create a user operator that then could be referenced over and over again. And I've saved that into a library called patterns. So now if I search for it, I can say, I can find this thing that I've created called neighbor distance. So if I plug these points into here, what's going to output is the distance to the nearest neighbor for every single one. All right, so that's what I went and found. For this point, it's this far away. For this point, it's that far away. And then from that, I could use that as a radius for some spheres. Sphere center radius. So there's the center. And then I could say the radius is going to be the distance to the nearest neighbor divided by 2. And then maybe I want some sort of buffer. So I'm going to say minus 1 millimeter. And then I could plug that into radius. And it doesn't work because structure's incompatible, behavior's unpredictable. Oh, because this flattens it all out. Yeah, that's fine. So that's another thing. What we're doing is we're creating a bunch of lists in here, right? This list happens to be in the form of a table. But what I've done inside of here is I've actually flattened it out. So if I say flatten, and now it's all flattened into just a singular list, now I've got a bunch of different sized spheres. Now, I have this other really cool thing that I can do where I can say, I don't want these to be evenly spaced. I want them to change their spacing dependent on a curve. So now when I do that, you see it's more spread out at the end and more bunched together in the middle, right? So this is where like you build in the intelligence and then all of a sudden you can make these like drastic changes and it's just kind of like wild. Like it's like, what do you, how, why, right?
If you imagine the work that it would take to do that in SolidWorks, you know, you wouldn't even try it. You would have to create each one of those spheres independently because they're unique. We can create like a variable pattern, but it doesn't work to that extent. And this is
Right.
just, and to be able to update it with that curve, I mean, you think about that, it's just like such a simple input for such a complex output.
Yeah.
And it's all visual and very easy to update. You saw how quickly it updated. So yeah, it's a bit of more work up front, Andy, to model it the way that you did with this graph editor, and that all looks new and different and probably has a learning curve that I'm actually interested how long it took you to learn this, but at the end of the day, making those tweaks, if this is like a design on like a sole of a shoe or you know, on some kind of packaging or something like that, you see some of those patterns and you're like, how the heck did they do that? I guess this is how, huh?
Yeah, this is literally how. So what I'm actually gonna do is I'm gonna make another change here. I'm actually gonna grab the neighbor distance for all of these because now they're no longer evenly spaced, right? And I've got this issue where these points are much closer together than these points are, right? But I kind of want them to all be like evenly spread out. So I can grab this distance right here, and then I can take the curve length. So now for each one of these, I've taken the length of that curve, and I'm gonna say, I'm gonna divide the length of that curve by the distance to the neighbor.
And while Andy's
Oh,
doing
whoops, I
this,
didn't do my
do we have a question from the audience at all, Mohammed?
Not yet.
Okay.
Yeah, let me see. But the way is really new.
Yeah, it's a very new, unique workflow for sure. Andy, why don't you pick us up on where you left off?
Yeah, so what I did is I said the length of each one of these curves divided by the distance to the neighboring curve, which gives me a bunch of, you know, numbers that have like a bunch of decimals, right? And then I said I actually want to divide them up into instances, right? And then what I did is, or actually I don't even need to do that, because that would be if I was putting in a number. Oh yeah, so I could do that. Yeah, that's why I did that. But I don't have to. So rather than dividing a curve by instances and saying each one of these has 10 instances on it, right? What I could actually do is divide the curve by length. So then I could say I want to divide it up by that length. And now what I end up with is a grid. Oh, it's because it's not a real number. It's because I took it. This is sometimes a problem. Is, you know how math is like the worst? Yeah, so it's actually respecting the fact that I took, you know, something millimeters and divided it by something millimeters, which means the millimeters cancel out. So now it's no longer a distance. It's just like a number, right? So I actually have to say, actually what I want to do is then my little trick is I multiply it
by 1 millimeter.
By 1 millimeter.
There you go.
Now then I got the unit back in there, right? So then I'll plug that into there. There we go. And now these are spaced out. And then rather than doing exact spacing, I do nearest spacing. And now they're spaced more evenly to the distance to the next cell. But that still like doesn't really look great, does it? Well, I guess it kind of makes sense. I think I'm gonna go back to this one though. I'm just gonna do floor, and then that is the number of instances.
This is a great.
Yeah, that's it. That's what I wanted.
Ah, yeah. All right. Yeah, so the quantity is changing.
Yeah,
from left
depending
to right.
on how far away they are.
Smaller, you could fit more little spheres on the curve. That's pretty cool. Wow. Yeah, so look how quickly that updates.
Yeah.
Andy, I don't know if you could zoom into that curve or not, but like
oh, like this one
in the chart view, yeah. Yeah. That's
it's basically
so Andy's tweaking the spline handles, if you will, on that 2-point spline. You can even change that into a multi-point spline, right? Like if you wanted to have more. Yeah. It's crazy.
So what it's doing is it's spacing out dependent upon the steepness of the curve. So the it looks like the flatter the curve is, the closer the points are together, and the steeper the curve is, the further they are apart. So now it would get further apart in the middle. Right, and you can create some scenarios where they just kind of look hilarious. But yeah, I mean, like usually you have like a nice blend that works out best.
I think you just showed it. Did you add that to the experiment panel?
I was gonna show the experiment panel in just a minute, but yeah, I could. I did not yet. But if you double click here, sometimes it'll like show up in the graphics area too.
Gotcha.
So if I click on that and I set that as a controller, now that's something that can, whoops, that is not the right thing to click. So now I could just be in the experiment tab, and that thing that I made visible then shows up over here, right? And then I don't even need to access the graph. So you could theoretically set this up for somebody else to use it, right? So I did want to
Somebody
I
like
do
me
wanna-
who doesn't know how to use 3D pattern shape creator, you could just
Yeah.
expose the parameters that I might want to change, and then I could play around with those without messing up your graph.
Right.
Right.
And something else I did want to show is there is this other thing that we're going to use a bunch, and it's this thing called a Voronoi. And what it actually does is it creates this big solid block cube thing. And then I can say, actually, I just want it to connect to this surface body. And then what it'll actually do is create these like separate like separations right there, right? And this is how we get this like crazy like blended hexagonal stuff that you see all over the place, right? But it's actually a more important node. There's actually this other thing that you get out of here called neighbors, and it's showing the neighboring, it's telling what the neighboring cell is. And actually, if I go back to this neighbor distance user operator that I created, it's actually referencing a Voronoi. So there's a Voronoi in there. And I wanted to show you real quick, like what a Voronoi is, because I think it's that important. So if I go back to here, yeah, I have like this. So you have different points, right? And then if you imaginarily draw a line between each point, and then at the midpoint of that line, you draw a line perpendicular, then you can kind of trim them all and create this cell, right? And it's actually illustrated pretty good, I think, by this GIF. So this is actually how this Voronoi thing is being created. You can also imagine like each one of these points has these neighbors, right? So this is the neighbor, this is the neighbor, it's wherever it borders. And this is actually a neighbor too, even though it's a very small one. And this is actually something that we see all the time inside of nature, right? This is how bubbles, right, would organize themselves naturally. A dragonfly wing, right? It's how nature decides to order itself. Giraffe.
It makes sense when you show that like little GIF animation, because things are just in nature organically growing until they meet the other cells or you know that are growing from the opposing direction. So it's pretty cool.
These are my favorite running shoes. They're using a Voronoi, right? They use a Voronoi to create this, and then they're actually using a Voronoi here, and they're calling up the distance to something else with the neighbor, right? And it's saying, dependent upon how far I am from this boundary, make the cell size different, right? So that's how you get these gradients in here. And I've got a bunch of examples of just that sort of thing, right? Where you can create like these blending kind of patterns. This is like the front of a shoe. Here's another grip that uses a Voronoi. And the really cool thing is how quickly you can update this stuff. Well, this one isn't quick actually, but you notice right here, these are a bunch of circles. This is actually for a building facade. Now I just put in whatever picture I want. You may recognize this guy. I think he came on your user group at some point, right? This is my friend Toby.
Toby. Yeah.
So I actually I grabbed a picture of him one day and threw it in 3D pattern shape creator. But we could also do is I could also go into here and I could make this a controller. And now right from here, I could change this and I could say, actually, what I want is the greatest NFL quarterback maybe who's ever been, right? And I'm gonna put him in there, and that's gonna load for a little while. What?
Tim Couch?
Tim Couch. That's a joke that's gonna be way over the heads of people outside of the United States who pay no attention to American football.
I was gonna say Russell Wilson, dude. He's at the Broncos now.
Nice. And while that's going, I'm gonna make a change over here, and I'm actually right now I'm inside of X shape, but what you're looking at is a basket weave, right? And this isn't like a texture that was applied. This is an actual weave that I created, right? You can actually grab the length of every single one of those individual pieces, right? And export that to an Excel document for manufacturing capabilities, right? And what I'm going to do is actually just come right in here and edit this subdivision feature that it was actually built from. And I'm just going to like make some drastic changes to this thing. Tim Couch, he says. Love it. And I'm going to go ahead and click OK right there. And this stuff, you know, understandably takes some time to update, but it's generating NURB geometry at the end of it. Like this is literally
really important
perfect geometry to bring back into SolidWorks to create a drawing from. Like it's not some like tessellated graphical rendering thing. It's the actual NURB geometry that it's building. So I mean, like if you imagine like how long it would take to do that in SolidWorks, I mean, like literally this can get on the level of like 10,000 holes. At that point, we've reached the limits of what you can do in SolidWorks. Like SolidWorks just if somebody comes to me and says I have a pattern that has 10,000 holes in it in SolidWorks, I'm like, I'm sorry, like you can't do that. You're gonna have to figure out a way to like fake it essentially for manufacturing. You can't create the actual thing.
It might be able to do it, but the reload time, comparatively speaking, is going to be ridiculously longer than what just completed just now for you.
Yeah, so that's the basket, right?
What was that? That was probably less than a minute, and it recalculated each individual strand of wicker or whatever that thing would be made out of. Because again, I'm sure there's a wicker shortage. And they would
you don't want to be wasted wicker.
I'm sure they wouldn't trim it after the fact, but very cool, Andy.
Yeah, and this was actually posed to me by there's somebody that was looking how to do this, because you may notice like they try now sometimes in you know, just stuff you go buy from the store, it's plastic, but they want it to look a certain way. So they make it look like it's got a wicker basket weave, right? So you probably wouldn't do this if you were making a wicker basket, right? Like you have somebody that's really good at it, or you have a machine that's trained to do it, right? But if it's plastic, right, you need to
in a solid
tooling. Yeah, you thicken it into a solid, put some like stuff around it, then you can create tooling directly from this.
Very cool.
So we should probably actually
were you so careful to make sure there wasn't any interference between, you know, the different strands, or?
I didn't have to be that careful. It was basically just there's a point right there in the middle, and I said offset that point out, and then I just went every other,
Wow.
right? Like that's all it's doing. That's all weaving is, right?
Yeah.
So yeah,
but it's impressive
there will be an interference eventually, depending upon how
tight the radius is on the underlying.
How close they get together. Like you would eventually experience like an interference. But you could also check that. There's a way to say like, as this it's like there's some measurement tools. Oh, this is in here. Actually, if I go over here, I go to measure, I can say like is laying on or is inside, right? So there's a way where you can ask it like, hey, like, is this like inside of something else? So you can do that.
So Andy, this is pretty fascinating. Love the different examples. I think we've got about like 15. Is it like 15 minutes left, Mohammed, or how much time do we have left?
Yeah, you got a time more. Hopefully.
Okay.
Let's probably actually open up the thing that we're actually gonna do.
Yeah.
But now that I've shown you like how to do it, I feel better about just kind of
It won't seem like black
quickly.
magic or
Yeah.
yeah.
So now I have this part here, and I just say, hey, I want to open it up over here. I don't need to save that example. And then I can kind of get started over here. Yeah, it finally came in. There he is. God, he looks glorious. That's Josh Allen from the Buffalo Bills. All right.
Yeah,
Take
no one
notes,
cares.
everyone.
All right, move on.
All right. So now I have these two bodies in here, right? And I'm going to get started by creating a design sequence. Click display graph. And normally I would have these on two separate screens, which is really nice. But in order for you guys to be able to see everything I'm doing, I'm just kind of chunking it out on one here. And I'm just going to start building this thing. So I'm going to say, first thing I'm going to do is I'm going to need some inputs. So I'm going to need that input right there. Of course, this happened to me right now. I'm just going to do a refresh real quick. I think because I was clicking around on a million different things, it got angry at me. Okay, we should be good. So once this opens back up,
have that in common, Andy. I get angry when you click around too much as well.
All right. So now I'll do input. Click here. I'll grab that. And then I'll do another input. And this time I'll grab that. And then I can do a split. And I'll say, this is the object I want to split. This is what I want to split with. And now it happened to guess the right one. But if I flip the orientation, right, it's the other side, right? So now I go, okay, this is the one I want. And now if I click here and hover over this, it says, hey, this is a geometric surface, and that's what I want to work with. So now what I could do is start dividing this thing up with some points, right? So I could say I want to split this thing by a plane, and let me see where my planes are. I don't have them shown, and I do want them shown. So yeah, if I split this thing up with this plane, so that's the XY plane. So I'll say intersect with that and the XY plane, which is actually giving me two curves, which makes sense, right? And then what I'll do is I'll divide each one of those curves by the same amount. So I'll say divide curve. It's going to divide both of them by the same number, and we'll say like 10. And then what I think I'll do is now I have a geometric point. Oh, did it not divide both? Oh, it's because they're the same. Yeah, so this is this weird thing that it's able to do, which Solidworks won't do, is you look at that, you go, that's two curves. But we have this idea of like sets, and I can treat them as one curve, right? So what I could do is I could say disassemble, and now I've got a bunch of different curves. And then I could say group by continuity, tangency, and now I've got two curves, okay? So now I can say divide those, and now it's going to divide both of them, and it has two columns, and there's 10 of them. But if I were to do a line right now, I'll say line 2 points. Or I can just say spline, will do. If I do a spline, it's actually creating two splines through those points. But I want it to be the other way. So what I could do is I could say transpose. I always mix those up. Transpose, and what it's doing is it's saying rather than this being a 2 by 10, I want it to be a 10 by 2. right? And now for each column, it will create a spline. So now I've got a spline that looks like that. And then from there,
opposing point on the other curve,
yeah,
versus the next one on the continuous curve.
right. So that's what I've decided looks good. And then I'll do an extrude. Or actually, here, what I'll do first is, for proper good surfacing practices, I'll do an extrapolate curve.
Extrapolate curve.
Yeah, it's kind of what we would think of as like an extend, but you know, we a lot of times we do extend surface. Yep. Here they would call that extrapolate surface, right? But they can do it with a curve as well. We could also do it with a, you know, you do convert entities and you drag the line away, right, to make it a little longer, but still the same thing.
So this way you don't get like, yeah, you're extending it past the extents of the surface, the underlying surface. Right.
Exactly.
Good
so now
idea.
I can say I want to go up by 50 and we'll go down by 50. And this is getting a little confusing, so I'll hide this and I'll hide this. Now we can just see what I'm working with here.
That as you're doing this, you're seeing everything update live graphically, because yeah, my eyes are locked on the left-hand side of your screen, just watching things pop up.
Oh, I went to try and divide the curve because I haven't done the intersect yet. So I want to do an intersection curve with the extrude, and then also with this other surface body here, which is actually my split. So what I could do is I could come back here and I could rename this handle surface, and then I could make it a favorite. And now when I come over here,
SolidWorks, it's good to name your features, and here it's good to name your nodes.
Absolutely. So then I could do another divide curve, right? And I could do like by 10, right?
So now
and now I
have points around those loops.
Right.
Cool.
So now if I hid that and hid that and hid that, and we'll hide this too. Now you can kind of see I start to get like a bunch of different points, right? And now I could start saying like, hey, what do I want to do with these points? And actually, the other thing I want to do is I want to make sure they're all lined up, right? You notice how like they don't all start at the same spot, right? And I want to make sure that they're lined up.
Right.
So another cool thing you can do is you can grab a point reference, PT ref, and from there I could just grab one column of points, which is these are the points, and I could say get item, and I'm just getting the first item, and then I could say that's the point reference, and now they're all lined up with each other, right?
And
Cool.
It's crazy how you just know what these things are called, point reference and stuff. But I guess like similar learning curve to SolidWorks, you need to know what the features are named, and you get aware of them.
You figure it out. You know, it's like you just know what it is. Like doing a sweep inside of SolidWorks. The first time that you do a sweep, you're like, no, that doesn't look right. I guess I'll try keep normal constant, whatever the heck that means, right?
Yeah.
And then you click on it and you go, oh, okay. It's just keeping all of the different sections of the sweep normal to the initial section, right? But what did those words mean in the beginning? Like, I don't know, right? I don't have a physics degree. I don't know what keep normal constant means, right? So yeah, I mean, like over time, I just
one of these little nodes has a help screen, like you showed, like the SolidWorks help kind of just flies out and explains things pretty well.
Absolutely. So the other thing that I could do at this point is, remember what I did before, where I basically drove this number by the distance between the instances? I could do that really quickly right here. I could go, oh, you know what? We're actually in a different cloud right now, but no worries. I still have that shortcut. So now this is on, and now I could say neighbor distance between each one of those points, and it's actually grabbing 20 items. So actually what I want to do is I want to grab the neighbor distance of these. And then from there, I end up with this value, which is pretty constant because it's
Evenly
right now
spaced.
they're evenly spaced. Yeah.
Yep.
And then I could do floor, and then I have like a round number. Oh, whoops. Oh, it's because it's doing it in meters, which is
As
really
you're
cool.
working through this, Andy, there was a question from the audience. Can you do everything online after having 3D Experience account? And yes, that is the case. What we've shown today is 3D Sculptor, which is the tool that I was using to create the handle shape. And then it would also be 3D Pattern Shape Creator, which is what Andy's using right here. And Andy actually hasn't hidden his Chrome browser tab, so you could see his browser over on the left, and then the graph view on the right is just a little extra window, but it is a browser window as well. So this is all being done online. What that means is like you don't have to worry about your computer specs and stuff like that. The crazy patterns that Andy was showing earlier that calculated like the basket weave that would have taken a day to calculate in SolidWorks was created here in like less than a minute. Yeah, that's all being calculated on the cloud through the 3D Experience platform, which is very convenient considering the flexibility of being able to work on any device.
Yeah.
So I bought you some time, Andy, and you still haven't figured it out?
It just keeps wanting to go to like real numbers. Oh, it's
Forget
rounding
real numbers.
to,
Come on. Multiply by 1 millimeter. That's what you taught us earlier.
well, so what I actually need to do, that's a good point actually, is just divide. If I divide by 1 millimeter, then I keep my number, but because what it wants it to, yeah. Anyways, now when I do floor, this is correct. And then I can multiply it by 2, and then I can say +1. And that way I'm ensuring that I always get an odd number, right? Because if I multiply by 2 and add 1, it's always an odd number. And then I can say multiply by 1 millimeter. Oh, but I don't even need to.
Yeah.
Because, oh wait, you know what it is that's the distance. This is, oh my goodness. That's the distance, and then I need to take the curve length. Oy vey.
See, we told you we were doing this live. Andy has never actually created this pattern before here. Truly figuring it out on the fly, which to me is like way more entertaining than a polished presentation.
Yeah.
The real world workflow of how a wizard like Andy like pieces together this logic. And you also start to see the flexibility and the adaptability of these nodes. Like he just changes the input from one node, those little like squiggly lines connecting the nodes together, to another so quickly. Like I'm always kind of like nervous how quickly he's working. Like, wait, are you sure you're picking the right thing? I would be like so much more I don't know, hesitant to work as quickly as he does, but it's pretty fun to see everything update live.
Yeah.
I have a question for Andrew and Jordan. Would you call this a non-linear workflow?
Yes. Yeah. Andy started touch a little bit on that, like how in parametric design everything is time based, whereas these nodes, you could see with all the connections that we're making with those squiggly line connections, you can connect any node to any other node, whether it's upstream, downstream, off to the side in a parallel little like process being computed. So is that what you were asking? It's pretty much like, you know, it doesn't have to respect the chronological order that something was built in. You can connect any node to any other node, which leaves for like an ultimate level of flexibility. Similar to what I showed with the ordered geometrical set in SolidWorks X-Shape. We're able to, by dividing chunks of geometry into different ordered geometrical sets, which are basically like folders. They appear as folders in the design tree. You're able to reference features that were created downstream in the design tree while editing features upstream in the design tree, which is a huge benefit when you're doing these edits that might affect one to the other. You're able to see how those interactions between those separate bodies will actually behave.
Yeah, it's work now.
It's a whole new way of thinking compared to the traditional SolidWorks feature tree that is iterative with a rollback bar, and your universe works in one of two directions, up and down.
Yeah. This is
a whole
like
new world of possibility.
expanding. This is like 4-dimensional. Yeah.
Right. Oh yeah. It's incredible.
It's remind me like a simulation that we got in neuroscience. That's
Yeah.
Like the way that all the neurons connect together.
Yeah.
A web of neurons. Yeah. So now I'll do.
Don't give Andy any ideas. He'll probably try to create like this vascular structure now on the handle.
I have no idea how big this thing is. So actually, I'll start smaller because I don't know the scale of this.
I don't either. I can find that out for you though. But expect it to be like 3 or 4 inches wide, 4 or 5 inches wide. There's our, yeah, nice. There's our Voronoi pattern.
And now what I could do is I want to change the thickness of the walls dependent upon how close they are to the edge here. So if I went to get the, yeah. If I go back to, wait, I can just do this. If I go boundary, and boundary is like convert entities essentially, right? So when I do a boundary of a face, I get the edges around the face or edges inside the face if there's a hole in it. So when I do handle surface, now I get those as boundaries, and then I can do the distance of every face, distance of the face to the boundary. And then, so I get all of these different distances. And then I could say, I want to have, we'll do length, and we'll call this one min offset. And then we want our min offset. Min offset looks pretty good at 0.25. And then we'll do another one, and I can just copy this one. And I could say max offset, and we'll say like 2 millimeters. And then what I could do with this is say stats, and it'll give me all the min, the max, the mean, but I also get this normalized, right? So normalized is it takes the max and makes it 1, it takes the min and makes it 0, right? So now everything's normalized in between. So now if I say the max offset minus the min offset, and then I multiply this by that, so now I have 1.75 as the largest value, right? And because I multiplied it, and the largest value is 1, and the lowest value is 0. And then if I add, so I say plus the min value. Now the highest number that I'll see in here is 2 millimeters, and the lowest number that I'll see in here is 0.25 millimeters. And then I've got all that figured out. So now I can plug that into my offset distance, and it will be specific to each face. Wait, but the closer it is to the boundary, the smaller it's going to be. Yeah, so then it gets bigger in the middle. Wow. So what I actually wanted is normalized inverse. And now it'll be smaller in the middle and bigger on the ends. So then what you'll see is, as the pattern
there and show us a little bit better. But you're basically changing the thickness of the Voronoi perimeter around that shape. Throughout the length of the grip handle.
Yeah, so I'll once it gets into 3D, it gets a little bit easier to see. So I'll just attach this face node right there, and now I'm going to split each individual face, and then I can do I have to be careful. You know how when in SolidWorks, when you do a radius and you just do it on like 100 edges, and then it wants to make them all 10 millimeters because you haven't put a value in. Yeah, then you're like,
this is cool. Parameters for the node before you actually connect it, and it's not going to recalculate it until you connect it to the other node.
Yeah.
There we go. Cool. Now we'll sit and wait.
And because of the law of my life,
got the inverted.
It always goes in the wrong direction every single time. It goes in the wrong direction.
It's like plugging in a USB.
Yeah. You know what else I could do is I could say I could do the normal, and then I could say multiply
You're a better man
that.
Because I would have just pretended like that's what I meant to do, because that looks equally cool when the inside's coming out.
But check this out. Now I'm gonna make it so they're smaller on the edge and bigger in the middle, like they come out more.
Oh geez.
Oh, but some of them failed. Oh, because some of them are 0, and that's fine. So it was like, hey, I can't do a thick at 0, right? So really, I could say plus like
0.001,
0.1 millimeters, right? And then plug that in there, and then I bet these all solve fine. Yeah. And now what I could do is hide all of this stuff. Now you just see that.
Yeah, it's really cool. Impressive.
You can see like the height of that is different.
Wow.
Yeah, and then
Dude.
And then the big thing is then I come back in here and I say I want to add a function parameter to that. And I do function editor, and I do something like this. And now it's going to spread everything out in the middle, or maybe it bunches it up. I always get them mixed up.
Continuously vary based on a curve, which is the coolest thing. Andy, I got to be honest, I was nervous. I didn't think you'd be able to finish this live, but you flew through that. And that was actually entertaining to watch, which really surprised me too, because like you'd think, it's a slower process than, wow, that looks pretty cool.
Yeah, some of these offsets though start to get ridiculous because of, so like you have to go like, how did I originally make this? Or you go like, hey, you know what? I accidentally stumbled on something that looks abstract and cool.
I think it looks abstract and cool.
Like, yeah, that looks kind of cool. I'm gonna go with it, right? But you have that flexibility.
Yeah.
Yeah. So at this point, like what we could do is I could then connect that back together with the rest of the handle. Actually, that part I can do like super fast right now. Is I basically just say I want to duplicate this, but flip the orientation. So now I have that other side that's split, and then I could combine them back together, click save, and then Jordan can open that up, and he can open it in SolidWorks. He can open it up in X shape, modify that shape, right? Like I showed you with the basket, you modify the shape and you can update it. But we've already gone way over time, so I won't bore you with that whole process, but I promise it spits back out on the other end and it becomes editable.
Zoom in closer to your awesome pattern so we can leave that on screen as if in case we have any questions to ask or answer. Yeah, so the question is, can this geometry be 3D printed? So that's a great question. Andy did cover this slightly. Not only can it be 3D printed, but all of the geometry is just as robust as if this were modeled by hand with surface modeling in SolidWorks. Every single surface is not like a tessellated approximation like some other applications that use this type of technology where you're using that big chart view to custom program, you know, where every single face is going to be and build your patterns like that. A lot of the time, the sacrifice there with those other applications out there is that it's creating tessellated geometry that can be 3D printed, but can't be brought back into 3D CAD very cleanly and, you know, shelled out and prepared for manufacturing, or like Andy said with the woven basket, like, you know, thickened and prepared for injection molding process or something like that. This is the highest level quality of geometry. It's the same geometry that we would get out in SolidWorks NURBS surfaces, where any point on any surface could be calculated to the, you know, 8th decimal place and predicted. So it's not an approximation or anything like that. It's using the highest quality of math in the background to convert all of these surfaces, which means they could be machined from, 3D printed, you name it. Anything downstream you want to do with it, you can do.
That's something to throw in as well. Like Andrew and Jordan have been saying, with the quality of NURB surfaces here, anyone involved in mold tooling, you can buy a CNC machine that's high quality enough that it will machine in geometry defects that you'll feel in your hand in the end product that will require hand cleanup on mold tooling. So if you're using tessellated geometry, like Jordan was saying, that stuff will show up in the final product and require rework.
Oh yeah, my gosh, yeah, that
deal.
would be a lot of rework. And you'd potentially lose out on a lot of the finer details that Andy's showing here too, like where it's blending the height of that thickness, that thicken value to 0. So it eventually, I mean, we're seeing the edges right there, but if you were to like print this out or manufacture it, the edges on the outermost edges would be invisible because they're perfectly smooth transitions. So it would fade away to nothing essentially. Another question was, you know, do all these processes since it's on the cloud, is it affected by internet speed? Yes and no.
Yes and no. Yeah.
So your live interaction with it, rotating the model, doing things like that would be affected. But as soon as you send that calculation to the cloud, that's fully dependent on our servers that are running the calculations. So that will not be affected. But then downloading the data and displaying it back on your screen will be affected. So a lot of the recalculation of this geometry and all that stuff is happening on our servers, independent of your specific internet connection. But when you're dealing with the model directly and clicking on surfaces, zooming in and things like that, that does you know, get affected by your internet speed.
I was just showing it. Bring it back in.
Is there anyone in here that's done surface modeling in SolidWorks? Can you get a +1 in the chat? Any surface modeling experience in SolidWorks? I'm just curious.
I know. I'll click +1.
Yeah, right.
Yeah,
So all of you guys know how long it would take to even try to get something like this.
Yeah,
with traditional surface modeling.
Totally.
And then trying to make a change, you'd be like, "No, I'm not making another change.
Don't touch it." Right. Yeah, you tell the guy at your desk to go home. It's not happening today.
Yep.
So there is a inside of Xshape and XDesign, there is a print 3D kind of thing where you can visualize it in your printer, and you can even like pull out like your specific printer, and like kind of visualize it in there. So you could even go as far as like analyzing it before you even click print, but obviously like directly from xGenerative design, you can actually directly export to 3MF or STL. And if here, I'm going to get on my soapbox for a minute. If your printer, if whatever printer you're printing to can take 3MF, use 3MF. STL was created in like 1982, and it literally has not changed since then. It's a bulky, kind of unintelligent file type that just has tessellated faces. 3MF, even if you don't have colors or textures or anything that you need in there, it will still make your file size significantly smaller. Use 3MF if you can. So yeah.
That makes sense. Well, Andy, I was thoroughly impressed by what you were able to pull off. Again, like, and the reason I say that, it sounds like a manufactured comment, but I truly haven't seen him create that pattern before. And
it honestly hasn't ever happened. I kind of wung it.
Yeah. So that was pretty cool that you were able to pull it off kind of on time. I know we're over, but if there are any more questions, let us know. And definitely, just like Muhammad did, feel free to connect with us on LinkedIn.
Yeah.
That one's a cool one.
Yeah. It's kind of the same idea, but like the size of the lumps are great.
I definitely try to do that for my mountain board design that you show in my presentation.
Yeah.
Nice. Yeah.
So I'm gonna modify it. Yeah, easy.
That would
Very
be
cool.
pretty cool.
Yeah.
Yeah, you could do a pretty cool grip pattern, or yeah, who knows what.
Yeah.
All right. Well, thank you everyone for your time. Appreciate it, and hope you enjoyed this this very new way of modeling, but very, very, very powerful way of modeling as well.
One more question.
And that pattern looks so good is because the subdivisional model underneath it is like beautiful.
he did make the sub D. It was very nice. Ahmed said, does it support motion or simulation? You can export this. Well, if you're using motion or simulation on the 3D Experience platform, there are tools for that. You just open up the physical product that you created here and you do your motion or your simulation on it. Because it's NURB surfaces, it's a solid, you can just run a simulation on it. You don't have to like do anything special. If you have SolidWorks and you have the connector for SolidWorks, then you can just, again, open the physical product. What it's actually doing is opening this file type called an SLD XML in the background. You can run your simulation, do your motion study, whatever. If for some reason you had no way to connect to the 3D Experience platform like directly with the connector in SolidWorks, and you wanted to bring in SolidWorks to do a simulation on it, or you wanted to send it to somebody else that doesn't have the connector, you can always export this thing as a step file. And because it's NURB surface geometry, it's a solid, that step file is going to come into SolidWorks perfect just about every time. And you can run your simulation on it as well. It says, got it, great. He was probably like, we get it.
Yeah.
Those steps are watertight, right, Andy?
Yes, totally watertight. The step file, I have never had a step file generated in xGenerative design come in with any failed faces inside of SolidWorks. Not to say that that can't happen, because you're dealing with like thousands and thousands of faces, right? So it's much more complex than like your standard bracket file, right? So there's a chance for it to happen, but if you have a newer version of SolidWorks, you're using 3D Interconnect, it doesn't even have to do that translation. So it should just always come in as a watertight solid body.
That's awesome. Thank you.
Cool. Now I'm actually done.
Thank you for your time, and Hope all is well in Sudan. Here from Cleveland and Boston, Massachusetts.
Yeah, it's cool.
Thanks, guys. That was fascinating.
Awesome. Glad you liked it. All right.
Take care,
Well,
everyone.
everybody, thank you so much.
I
Let's
really
go plus
appreciate
one
it.
in the chat for these guys. Thanks.
Yeah,
Woo.
thank you so much.
All right. Well, I'm signing off. I will see you guys later. Thanks again.
All right.
Okay,
Thank
thank
you.
you so
Take
much,
care.
Andy. Take
Bye
care.
now.
Another great meeting, Mohammed. Way to go, man.
Yeah, I mean, how about you? How are you?
I'm doing well. I gotta run too. I gotta get working on everything today. It's still early morning here in Seattle.
Yeah, a lot
You
of
doing
stuff.
okay?
Yeah, things to drive to a good stuff.
Good deal. How do you say goodbye in Arabic?
No, just a little brief. Anybody got any suggestion for a new presenter, like a specific topic or something like that? So it would be cool.
When
Yeah,
we
here,
have
yeah, here we do a similar stuff like champion.
when we're gonna see you next Friday for Champion Central Live.
Yes,
Sweet.
definitely. Yeah.
That'd be good. And what's goodbye again?
مع السلامة. It's long one.
It's way long. Say it again.
مع السلامة.
Mastarama?
مع السلامة, yeah. And the first one that I teach you is marhaba.
Marhaba, which is
how are you?
how are you? Okay.
Yeah.
And after that, Mastarama.
Yeah, so,
Take care. Bye-bye.
bye. Yeah, see you guys. Yeah, thank you guys for tuning in. See you later. Hope to see you inshallah in next meeting.